Welcome students. Let us discuss a very important topic from the chapter complex number. The topic is modulus of a complex number. This is very interesting. So let Z be a complex number which is equal to a plus ib. Then modulus of Z is denoted by this notation mod of Z, which is equal to root over a square plus b square. That is mod of Z is equal to root over a square plus b square. Correct? It means a real part of Z, this square, plus imaginary part of Z, this whole square. And this value is always positive. Okay? Modulus of Z is always positive. We will discuss it during this video that why modulus of Z is always positive. Correct? So we can understand it very easily now. Let us say take a complex plane, or you can say argand plane. Here x o x dash is x axis and y o y dash is y axis. Suppose point P is here having coordinates a b, then geometrically this point P denotes this complex number Z having real part A and real part B. Here this is A is real coordinate and B is imaginary coordinate. A is taken along real axis, x axis, and B is taken y axis along imaginary axis. Correct? And if this Z, this complex number, is denoted in polar form like r cos theta plus I sin theta, then this distance OP, this is r, or this distance OP is modulus of Z. So in this diagram, in this argand diagram, here we can understand that OP is mod of Z, this is equal to R in polar form. So because OP is a distance, so this is always positive. It cannot be negative, never. Okay, this is always positive, and in polar form we write R here. This distance OP is R, which is equal to modulus of this complex number. Correct? Now we are going to discuss some very basic properties of modulus of a complex number. Okay, some basic properties of modulus of complex number. First, mod of minus Z is equal to mod of Z. Modulus of minus Z and Z both are equal. We can understand geometrically also. In this case, minus Z will be a complex number minus of a plus ib. Okay, so minus of a plus ib will have coordinates minus a minus b, which is image of this point with respect to origin. Here P dash is image of point P having coordinates minus a and minus b. So in this case also OP dash is distance from origin, so this is always positive, and since P dash is image of point P, so distance of here OP is equal to OP dash. Okay, this is modulus of complex number Z and this is modulus of complex number minus z. Here OP is equal to OP dash, so mod of z is equal to mod of minus z. Very simple. Second, mod of z bar is equal to mod of z. You know z bar is a minus ib. So its corresponding coordinate of z bar, coordinate of the respective point which represents z bar is a and minus b. And a and minus b will lie in which quadrant? Fourth quadrant. So this will be image of point P with respect to x-axis. Okay, suppose this is P double dash. Here coordinate is a and minus b. So this is the modulus of the complex number conjugate of z. So in this case, O double P dash is also equal to OP, because this is image of point P with respect to x-axis. So O double P dash is equal to OP. That's why, you know, this point P represents z bar, conjugate of z. A minus IB. Real part is A, imaginary part is minus B. So this is P double dash represents conjugate of point Z, which is point P double dash is reflection of this point P with respect to x-axis. So distance OP is equal to distance OP double dash. So modulus of Z bar, this one is equal to modulus of Z. Okay, this is modulus of Z bar OP double dash, and this is modulus of Z. Both are equal, correct? And third rule, third property, Z1 into Z2. Here Z1 and Z2 are two complex numbers. Okay, and modulus of Z1 into Z2 will be equal to modulus of Z1 into modulus of Z2. Understand it very clearly. Okay, modulus of multiplication of two complex numbers is equal to multiplication of moduli of respective complex numbers. Okay, so this modulus has been distributed over both the complex numbers Z1 and Z2. That's why modulus of product of two complex numbers is equal to product of moduli of these two complex numbers. Similarly, in case of division also, Z1 by Z2, this whole modulus of Z1 by Z2 is equal to modulus of Z1 by modulus of Z2. We have to remember these rules, this formula. We have to apply these results in solving the problems. And fifth, complex number Z into Z bar is equal to modulus of Z whole square. Because this is Z into Z bar is equal to modulus of Z square. Because this is A plus IB, this is A minus IB. When we will multiply, we will get A square plus B square, which is square of modulus Z. So you have to remember it. And one more property, if modulus of Z is equal to 0, this is possible only when, means this implies that complex number Z is 0. Okay, if modulus of Z is 0, then corresponding complex number Z is equal to 0. Correct? Because you know that modulus is equal to square root of real part square plus imaginary part square. So this will be 0 only when complex number z is 0. And 0 is also a complex number, we should know, because 0 is nothing but 0 plus I0. So 0 is also a complex number. And this property is vice versa. Means if modulus of z is equal to 0, then z is equal to 0. And if z is equal to 0, then modulus of z is equal to 0. If and only if, vice versa. Correct? So we are supposed to remember this properties of modulus of complex numbers, and this is the definition for modulus of complex number, and this is the geometrical concept about modulus of complex numbers. Correct? Very interesting, very simple, and we have to apply these properties in solving some problems. So remain in touch with these videos. We have to see some more important questions, and share this video with your friends also. Wish you all the best.